Today we're talking about graphing linear equations. Very important skill that we have, and this is a very important chapter coming up. There's a lot happening in it, so it's really important that we understand how all these things work as we go. So what is a linear equation? Linear, if I say something is linear, it's an equation whose graph is a perfect straight line. The points on the line are called solutions of the equation. So it's not just that we have a pretty picture on our graph. So let's look at an example. Graph each equation using a table of values. I don't want us to worry about this, so I'm going to get rid of this for now. This is not something that we want to do. We want to focus on how to make a table without any restrictions. We're going to get rid of that. Okay? So a couple of things. We're going to make a table. So you must have at least 3 points for your table. Now, reason for that is because we are saying that this should be a straight line. If somehow you make a table and you don't have a straight line, something's not right. If you only plot 2 points, then you won't know if it was right or not, because 2 points, if I connect them, would definitely make a straight line. We have to make sure that we at least have 3 points to verify we have a straight line. So how do I make a table? So basically we make one of these tables that you can see here, where we have an x value. We can see this equation that we're asked to make. We have the y values. And then we have this column over here, which will basically become our solutions. So here's how we do this. So we're going to pick an x value and plug it in. So you pick any x. Basically, you can pick any x's you want. I would personally like you to try to be a little bit more strategic in that. Pick easy ones. Pick nice numbers to work. Don't pick giant numbers. Don't pick weird numbers. Try to pick numbers that will make it as easy to calculate as possible. Let's start with -2. So let's say I want to plug in -2. So the second column here says I'm basically going to replace the x with a -2. So that's what that means to plug in. I've replaced x with a -2. Now I would just follow order of operations. So -2 times -2 is 4, and then I add 1. So 4 plus 1 is 5, which means when -2 went into my equation, y was a 5. Then I move on to another one. So let's just keep in the same order. Let's pick -1. If I plug in -2 times now -1, what do I get? Well, if I multiply those together, I get a 2 plus 1. The y would come out as a 3. 0. So 0 is a great number to pick. The reason 0 is a great number to pick is look what happens. -2 times 0 plus 1. So unlike the other two, where I had to think about, well, what's -2 times -2, or -2 times 1? What is -2 times 0? It's just instantly 0. And then I add 1. So it comes out as a positive 1. So -2 is a great one to consider anytime you're trying to make a table. Then let's just move on. We would like to have at least some negative, some positive, and the 0. So if negative 2 goes in, and I multiply it now by a positive 1, negative 2 times 1 is negative 2 plus 1, which is now a negative 1. And let's just go one more. Negative 2 times a positive 2 plus 1 is negative 4 plus 1, negative 3. So the first part of our table is basically to show making up whatever x's you want to pick, but trying to be strategic. And we didn't need to do 5, but we want to show you 5 on this first one at least. So then this last column, x comma y, these are going to show me the solutions, which basically are what we're graphing. We're graphing the solutions. So one of my solutions, we said negative 2 went in and 5 came out. So I can plot that point. Then I would say if negative 1 went in, 3 came out. Now I can plot that point. If 0 goes in, 1 comes out. I can plot that point. Negative 1 comes out when 1 goes in, and when 2 goes in, negative 3 comes out. So the whole idea of all of this table work is that we are trying to create this column of solutions so that we can show it on a graph. So now on the graph, let's really make sure we understand some things. And it's going to be hard for me to do this, but you hopefully will understand what should happen. We first want to make sure we're using a straight edge. So I won't have a nice straight line because I'm trying to draw this on a tablet. You should be using a straight edge. Remember, the one going up and down is your y-axis. Then when I come across, this is the x-axis. Now I plot my points. So negative 2, 5. I would come across 2 to the left and up 5. There's negative 2, 5. Negative 1, 3. To the left 1, up 3. There's negative 1, 3. 0, 1. Now remember, 0 doesn't mean anything left or right. I come up 1 to be there. 1, negative 1 is 1 to the right, 1 down. 2, negative 3 is 2 to the right, 3 down. So there are my points. It does appear they seem to be in a nice straight line. If one of them was not correct and it was not in that line, that would tell me that I need to do something different. Then with my same straight edge, what I would like to do is connect these with a nice straight line, arrows on both sides, because really this graph is only like zoomed into this area. This should continue to happen forever and ever and ever if I just kept adding more x's. And then the last thing I want to do to show everybody what my graph looks like, I want to write the equation as a label on my graph. So I'm going to write y equals negative 2x plus 1 to show everybody that is the graph of that equation. So a couple of quick things that I want you to really think about. Always include some positives, some negatives. Always consider using that 0 for the x, because that makes it easy to solve. Because whatever times the x, once you plug in a 0, it just disappears. And then you can fill out your second y value a lot easier, I think. So a couple of things that you want to be considering. And you have to have at least 3 points. So let's move on to these things called horizontal and vertical lines. We all know that a horizontal line is a perfectly straight across flat, like the horizon. So basically, when I get this kind of a graph, this is an equation, you'll notice, with no x. When I see this equation with no x, so for example, right here we have y equals b. So notice there is no x on the right-hand side. And that b really could be any number. So let's just kind of say y equals 5. that would be telling me there's no x's over there. But y equals, usually we think of that as a variable, but they're telling us it's a graph. So an equation with no x is going to produce our horizontals. And on the same idea, looking at this next one, x equals a number. If I have an equation, and again, if they tell me it's a line, if they tell me it's something that I need to graph, but I don't have any y, it's just the x's, we know that it's going to produce a vertical line. Kind of hard to understand maybe initially, but we're going to do a couple of examples to kind of hopefully show why that is happening. So here we have two graphs that were being looked at. The first one is y equals -3. So we first want to say, well, is this a variable I'm plugging in, or is this a graph? This is an equation. Well, they're telling us to graph it, which means that this is definitely an equation. So what I want to do is first draw my x and y axis. So remember, the tall, long one is my y. The one that's horizontal is the x. Now remember, as we just said on the previous one, if there isn't any x in the y, it told us which one we were talking about. But let's just kind of quickly just show a table over here. So here's an xy table. So let's just pick some numbers. So what if I said x was -2? Well, is there any place to plug in x up here in this equation? There's no place to plug in x. But what is y? Y is -3. Okay, so let's just say -1 is x. Is there any place to plug in the x as a -1? No. But what is the y? It still says -3. Okay, what if I plugged in x as 0? Well, again, is there any place to plug this in for the x? No. But what I know is y is always still -3. So with that in mind, when I go to plot these 3 points, I would have had -2, -3 would be there, -1, -3 is there, 0, -3 is there. So no matter what I plugged in for my x values, it never changed the fact that y was always -3. So that's where the horizontal comes in. And I want to make sure I put my equation on top of my graph. That is the graph of y equals -3. Now we want to compare that to this next one. Again, I want to draw my y-axis and my x-axis. So this time, x equals 2. And again, I know that it's an equation because it says to graph it. It doesn't say it's a single variable. So again, if we use that same idea over here, this time there isn't any y. So it doesn't matter what y's are. Y is not going to change the fact that x's are always 2. No matter what I want to make y's, x's are always 2. So this time, no matter what y is, so if y was 0, x's are 2. If y's are 1, x's are 2. Y's are 2's, x's are 2. And then you can then see that's where the vertical line comes in. So no matter what y is, x equals 2. That's where that graph comes in. The verticals are going to be the x equals whatever number it is that it's crossing the x-axis. Lastly, we have a real-life situation. We want to see what a hurricane storm is doing for us, and then show it on a graph. So the wind speed y, you gotta keep that in mind, of a tropical storm is with this equation, y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. When does the storm become a hurricane? Well, before we get anywhere near answering that, let's make a table. Now let's think about this. In this case, will we have anything that would be negative? Am I going to have negative time, which would be the x, when it enters the Gulf? Am I going to have negative wind speeds? No, everything in this situation is positive. So because of that, this is a case where I'm not going to use any negatives because it wouldn't make sense in this case. So what I'm going to do is I'm going to pick only positives, but I'm also going to pick 0. So the very first number I'm going to plug in is 0. So again, we're going to plug it in to the equation that they are giving us to proving the wind speed. 2 times 0 plus 66 is 0 plus 66. So when 0 goes in, 66 comes out for the y. Then let's go an hour later. An hour after it enters the Gulf, I plug in a 1. I get 2 plus 66 is 68. And let's go 2 hours after. I would get 4 plus 66 is now 70. And I'm not going to go further than that. I think 3 points should be enough if we did this correctly. So remember, once I have 3 points at least, when 0 goes in, 66 comes out. That now is one of my solutions, 0, 66, that I can use on the graph. When 1 goes in, 68 comes out. There's another solution. And when 2 goes in, 70 comes out. There's another solution. So now I can go to my graph. So there's a couple of things on this graph I want to help you remember about graphing, and then also make sure we're being consistent. Now in this case, we know that our quadrants, if I was to make a graph, would be positive, positive for my x and y's, would be negative for my x's, positive for y's, would be negative, negative, and would be positive, negative. Now notice our 3 points, they're all positive, positive. So our graph, we're not going to show all 4 quadrants, we're just going to focus on the first quadrant. So when I go and make my axes, notice how I'm doing this. I am only showing positive quadrant 1. Now also, I'm not going to put x and y this time. I'm going to use labels because it's a real life problem. So down here, we're going to put hours, representing the hours after it enters the Gulf. And we're also going to put over here miles per hour to represent our wind speed. So you need to make sure you include those labels. Now, looking at our numbers, we have some crazy numbers here. We have 0, 1, and 2 for the x, but then we have 66, 68, and 70. Those are pretty big numbers. Now remember, you don't have to have the same scale on the x-axis as the y-axis, but they do have to be consistent on their own axis. So what I'm going to do here is this. For my x-axis, I'm going to actually go up by halves, half an hour. So my first hour is going to be here. So we start at 0 and then I go to 1. Then I'm going to skip to 2. Then I'm going to skip to 3, 4, and 5. But on the y-axis, if I do that, it'll be so far up in the air before I get to 66. So on the y-axis, I'm going to do this thing, hopefully you remember seeing these in the past, called a break. It looks like kind of a sideways Z. This break means I am jumping way up, and that first little box is not the same as all the rest of them. So I'm going to actually go by 2s because 66 to 68 to 70 look like a good 2s. but I'm going to jump all the way up to 62. Actually, I'll jump to 60. But that break allows me to say from 0 to 60 is one block. But then, because it was a break, now I can go by a new scale. So this is the way that I can jump up, but still get my numbers to be accurate. So the first block I went up by 60, giant jump. But then notice 2, 2, 2, 2. So it's okay to do this to kind of help zoom into that area. So now I can plot my points. So if I'm plotting my points, 0, 66, sitting right there. 168 is sitting right there, and 270 is sitting right there. And they do seem to be in a nice straight line. Okay? So then what I want to do is I want to make sure I'm drawing a nice straight line as best that I can. And then this time, I'm not going to draw an arrow on both sides because remember, while yes, this would continue this way if I made a graph on all 4 quadrants, we're not going to have 0 hours, negative 3 hours down. So I'm only drawing my arrow over here on this side, saying that it's going to continue to go up. So then I want to say, here's my graph, and this looks like a nice graph. How is this going to help me answer the question? Well, back up here, it talks about a tropical storm becomes a hurricane when it's at least 74 miles an hour. So I want to look on my graph. Where is it 74 miles an hour? Well, it's right here. So if I follow across where it hits, which is right here, that goes with this number 4, which means it'll be 4 hours when this becomes 74, right there. So I would answer my question as 4 hours to become a hurricane. Now, just as a proof on so we didn't do this initially, but let's just say we think that it was at 4 hours, right? So let's say we had plugged in 4 way over here. Plus the 66 gives me 8 plus 66. There's the 74. That is my y value. So had I continued my table, I could have seen my answer right here, but this is my answer. In 4 hours, it'll be 74 miles per hour. So this is a very important skill to be able to make a graph. We want to make sure we understand how that works by making that table. If you have any kind of questions, please feel free to let me know, and we can help go over it more together.